Let's start by pulling in the image for our illustration. The image is bigger than we'd like. We can give it responsive sizing using CSS variables and calc. Here we use a size variable with a viewport unit. That gives us a responsively sized image. We can check this by resizing our browser window. Let's center that image using position fixed with a combination of top, left, and transform. Now we need to do a similar thing with our container. We can center it using the same technique. At this point, we have an opportunity to reuse our styles. Let's do that. We have our egg container, but it currently has no size. The height and width are both 0. We can confirm this by referencing the computed styles. How do we size our container? We can use the same height as our image. But our image has an implicit width. To give our container a width, we can create a responsive unit. This unit we can use to power our CSS illustration. To calculate this unit, we can use the intrinsic height and width of our image. We can check this with our browser's DevTools. Here we can see our image has a width of 742 and a height of 769. To define our unit, we can use calc by taking our desired size, dividing that by our largest intrinsic value, and multiplying by a desired coefficient. And we can test this on our container by doing a height of our intrinsic height, 769 times var unit. And we can do the same thing for the width using the intrinsic value again, 742 times var unit. We can apply a background color so we can see our container. If we use the HSL or RGB color space, we have the option of using a reduced alpha. And there's our container. This container will scale responsively with our image. The height and width of our illustration and the height and width of our image will be the same. So we can move the height and width, and we can remove the height here. What we may choose to do is reduce the opacity of our image. Using a reduced opacity on our image and the elements we create makes it easier to compare our illustration to the image we're trying to create. So in review, we created the foundation for our illustration by pulling in the image we're going to create and then creating a responsive container that we can use for our illustration that is powered by a responsive unit which we calculated using the intrinsic width and height of our image. Now that we have the styles in place for our responsive container and the responsive unit defined, it's a good time to plan our HTML markup. Create and split the markup based on the features of the illustration. In this illustration, one containing element for the shell and one containing element for the spectacles. Once we've created the containing elements for the feature pieces of our illustration, we can decide on the elements we need to make each feature. Looking at the shell, we might think of using one element. But if we look closely, we can see that the outline of the shell is offset when it goes behind the spectacle lenses. With that in mind, we likely need more than one element for the shell. We might try using pseudo elements or two elements where we have one for the inner shell and one for the outer. But let's make things easier for ourselves by using 3 explicit elements with the class shell piece. We can use the shell piece class to share styles between the different pieces of the eggshell, namely the border property and the background color. We can use extra classes to distinguish between the top of the shell, the middle of the shell, and the bottom of the shell. Next, let's plan the markup for the spectacles. We have 2 lenses, a bridge, and the arms. Let's create the elements for them. An element for each lens, an element for the bridge, and an element for the arms. We can use extra classes to differentiate between the left and right lens. Both lenses have shared styles, but are a mirror image of each other. We can create the spectacle arms with one element, but as we can see, the arms need to sit behind the shell. To do this, we can move the specs arms outside of the specs container and below the shell in the stacking context. This means that in our illustration, specs arms will be first, then the eggshell on top, and then the spectacles on top of the eggshell. So in review, we've planned the markup for our illustration. We've created the elements we feel we'll need to create the illustration. And we've also taken into consideration the stacking context. In our example, the spectacle arms will need to appear beneath the shell, whilst the spectacles will need to appear above the shell. We have some markup for our egg. Let's style the shell. Let's start by applying a background color to our shell container. Using a color with reduced alpha makes it easier for us to make comparisons with the image we are trying to trace. We won't see our shell element until we define a width and height for it. At this point, we have a decision to make. We can either use the responsive unit we defined earlier, or percentage-based values for sizing things in our illustration. Let's use percentage and go with a height of 90% and a width of 70%. We want to center the shell in our illustration, so we can use position absolute with a top of 50% and a left of 50%. And then we can use transform with a translate of -50% on the x-axis and -50% on the y-axis. And that centers our shell in our illustration. We can see the size of our shell isn't quite right. It's not quite tall enough, and it's not quite wide enough. Using DevTools, we can tweak the dimensions of our container, where 95% looks about right for the height, and 74% looks about right for the width. Let's update those sizes in our CSS. Next, let's work on the pieces of our shell, starting with the top. We want to be able to see the image underneath, so let's start by defining an opacity of 0.5. We can start with a height and width of 100%. And let's go with a background color of purple. To get that curved shape, we can make use of the border radius property. Border radius not only allows us to create more basic shapes with a uniform radius, but it also allows us to create more complex shapes using the / notation, where the first 4 values are for horizontal radius and the second 4 values are for vertical radius. For our radius, we're saying 50% horizontally for the top 2 corners and 85% vertically for those top 2 corners. If we look closely, we can see that the shape isn't quite there. It's not quite filling the width. Much like we did with the containing element for our shell, we can tweak the styles to try and make the shape we want. Here it looks like stretching the height and increasing the width will get us close. However, we've hit an issue. Our eggshell piece is no longer centered in our eggshell container. Let's add the styles for that. Using position absolute, we want the shell to be aligned to the top of the container, so a top 0, but we want this piece of the shell to be center aligned regardless of its width. We can use left 50% with a transform translate of -50% on the x-axis and 0 on the y. Now we can revisit DevTools to tweak the styles and create the shape we need. So let's add them to our CSS. Now we've got the shape we want. How do we clip the element across here? For this, we can use a clip path with a value of inset, where the 4 containing values equate to the top, right, bottom, and left sides of our element. If we change the bottom value of our inset to 50%, that will clip off the bottom 50% of the element. Once again, we can jump into DevTools and tweak the styles to find an appropriate value. So let's update our CSS with the 70% value. And we also need to define the border for that outline. We can use our responsive unit that we defined earlier with the color we defined for the shell outline. We can see that our border isn't quite thick enough, so we adjust the values until we find a border that we're happy with. Lastly, we apply the background color, and that's the top part of our shell. We can follow the same process to create the other parts to our shell. Let's start with an opacity of 0.5, a height of 100%, and a width of 95%. To see what we have, apply a background color using the shell variable we created. This piece will also need to be center aligned. Let's apply the same border that we used for the top of the shell, and let's also attempt to use the same border radius. We can see that the width isn't quite there, so we can use DevTools to increase the width to something we're happy with. Apply that to our CSS, and we're ready to clip our element. We can use the inset clip again, but this time we need to clip from the top and from the bottom. A top value of around 30% and a bottom value of around 40 to 50%. Putting those values in gives us a shape that's quite close to what we want. However, we likely want to bump up that top inset value slightly so that our border doesn't show or peek out above the spectacles. Let's try 32%, and that looks great. Last up is the bottom of our shell. The same process applies again. Use the same background color and the same border. The bottom of the shell needs to be positioned at the bottom of the shell container, and it looks almost circular. So we can try a border radius of 50%, a width of 100%, and let's try a height of 60%. And we need that reduced opacity to see what we're doing. If we try increasing the height in DevTools, we may be able to get the shape we want. A value of around 76% looks about there. An alternate approach would be to use a height of 100% and a more complex border radius value where we utilize the / notation to gain finer control over the curve of our element. This emphasizes how there's normally more than one approach to what we want to achieve. The last piece for the bottom part of our shell is to use a clip path, but this time we are only interested in clipping the top part of the element. 50% doesn't quite cut it, so how about 58? And that looks pretty good. Now that we've created our shell with the different pieces, it wouldn't be a bad time to refactor those shared styles. We can extract the common styles from one of our shell pieces, where we reuse the background, positioning, the translation, and the border. Let's remove some of those duplicated styles. That way we can check that we've refactored everything correctly. We could refactor this slightly further, but for now let's leave it there and remove these opacity declarations. We can also remove the background color for our shell container, and that's our eggshell complete. So in review, we've created our eggshell by using one containing element and then using elements for each part of the shell, the top, the middle, and the bottom. And these are positioned relatively to that containing shell element. We've used border radius to achieve these curves, and we use a clip path inset to clip off parts of each shell piece that we don't need to see. We've looked for opportunities where we can share styles across classes, and we've done so with the shell piece class by sharing things such as the background color, the border properties, and positioning. Now we've created the shell for our egg, we can focus on the spectacles. Let's start by hiding the shell. Next, we can style the containing element for our spectacles. We can use the same technique where we use a background color with a reduced alpha to see our container. That container needs both a height, which we will set at 30%, and a width that we will set at 90%. We want to center the spectacles, so we can use position absolute and use a left of 50% and then use transform, translate, minus 50% on the x-axis and 0 on the y to center the element. Using a top value of around 30% should position the spectacles where we want them, and we can see that we are nearly there. As we did with our shell pieces, we can use dev tools to tweak the styles until we get something we are happy with. A width of around 95% looks good. A top of 31% is too low. A top of 30% is too high. So 30.5% looks about right. Lastly, we tweak the height. 31% looks too big. 30% looks too small. 30.5 is about right. Let's update our CSS with those values. And now we have the container for our spectacles. Now we're at a point where we can start creating a lens. Let's start with a reduced opacity and a random background color. Next, we can define a width and height. Let's go with 45% width and a height of 90%. It looks like our lens is almost 200% height, but it isn't, because that is both of our lenses. Let's use position absolute, and now both lenses are on top of each other. We can reduce the opacity to make things a little easier to follow, and we need to rotate the lenses to match our image. We can use transform with a value of rotate to rotate our lens by the number of degrees specified. We can see that a positive rotation isn't the right direction for us, so let's try rotating the opposite way. At this stage, it's a good idea to jump into DevTools, and we can start adjusting the styles to our needs. We can see our lens needs to come down from the top a little bit, maybe 1%, 3% looks good. Can adjust the height, and maybe we can come in ever so slightly from the left too. Let's update our CSS with those styles, and now we can use a complex border radius, like the one we used earlier, to create our eggshell. We use the optional / to define both horizontal and vertical radius for each corner of our element. Here we've estimated the values to create the shape we want. Jump back into DevTools and we can adjust the border radius until we get a shape that we are happy with. We might decide that left 1% is no longer required to line this edge back up, and we might decide it's more important for this corner to try and match with our image. So we can adjust that part of the border radius until we have something that we are happy with. The last part for our lens shape will be trying to tidy up these corners with the horizontal values, and we can adjust them until we find something that we're happy with. Once we have something, copy that value and update it in our CSS. And don't forget to remove the left property that we turned off in DevTools. Now we can remove the background color and apply a border. We will use a solid border, but we can use our responsive unit to define the width. That gets us pretty close. I might bump this up slightly to 44. To take this further, we can move our color into a variable at the top of our style sheet. Remove the opacity style from our lens element, and there we have our lenses overlapping. So in review, we've styled both of our lenses as the left lens of our spectacles. We created a container, we styled the spectacles container, and then we styled both lenses as if they were the left lens. We use a complex border radius to achieve the curved shape, and we use absolute positioning and transform rotate to position the element exactly where we want it. We've also considered the trade-offs when we create these types of shape, and when we create CSS illustration, more often than not, it's a case of finding a shape that we are happy with that may not be 100% correct. Now we're ready to style the second lens, our right lens. It needs to be on the right side of our container, so we can use a value of right with 0. But now our transform value needs to change. Where we were defining a rotation of -10 degrees, we now also need to rotate the element on the y-axis to mirror it. Now our rotation isn't quite right, so maybe +10 degrees will work. And it does. Because by default our lens is styled to be the left lens, we don't need to use the left lens class. But the right lens class we can use to override the shared styles and position our right lens accordingly. So in review, to style the second lens, or the right lens, we've used the shared styles from the specs lens class, but we overrode the positioning and the transform to get the desired result. Now we're ready to style the bridge for our spectacles. If we look at the bridge, it has this round top. To achieve that, we could use an element that's much bigger and then clip it. Let's start with reduced opacity and absolute positioning. Let's try a height of 100% and a width of 30%. We can see the bridge isn't quite at the top of the container, so a top of 2%, and we use a left of 50%, and we use transform with translate to center the element, translating it negatively 50% of its own width, and try a background color of purple. That doesn't look too far from what we need, so let's remove the background color and swap it out for a border. We can use our responsive unit, a solid border type, and the color we defined earlier. Jumping into DevTools allows us to adjust the styling, so we can make adjustments until we find a shape we are happy with. Once again, it's about compromises, and it's finding a shape that we are happy with. The more accurate we want to be, the more complex our illustration will get. Let's apply those styles to our CSS, and now we're at a stage where we can use a clip path again to clip the unwanted parts of the element. We can use inset. We don't want to clip anything from the top, so 0 for the top. Let's try coming in about 20% from the right and 20% from the left, and maybe 60% from the bottom. So 20% right, 60% bottom, and 20% left. And that looks pretty good. The last thing we need to do is remove the opacity declaration. And now our spectacles are starting to take shape. So in review, we styled our bridge element using a basic border radius on an absolutely positioned element that we then use clip path on to clip off the excess that we don't want to see. And this gave us the bridge shape that we wanted. The last element for us to style are the spectacle arms. We have to remember though that these aren't inside the spectacle container anymore. So we need to be mindful of that when we're doing any positioning or sizing. That is based on the egg container and not the spectacles container. With that in mind, we can remove the background color from the spectacles and start styling the spectacle arms. We might find it easier if we first hide the spectacles. This allows us to focus on styling the spectacle arms. We follow the same process as with our other elements, beginning with a background color, and then we estimate a height and a width. Let's reduce the opacity so we can see the trace, and then let's center align by using position absolute, left 50%, and a transform translate of -50% and 0. Then we need to define a top value to position the arms where we want them. Let's try 35%. That looks quite close, but the width is maybe too large. So let's knock that down to 90%. At the same time, we can see this corner is slightly overlapping where our lens might go. So let's bump the top value to 36. We are going to use a different clip path value to clip parts of our element away. To make this easier, we can try and align the bottom of our element with the baseline for the two spectacle arms in our image. We can do this by reducing the height. When we clip the element, we will be clipping from the top left corner across and down, and then we will travel across, back up to the right corner, down, cut off this corner and go across, and then cut off this corner. Any parts of the spectacle arms that overlap the eggshell will not be seen. That is because the spectacle arms are below the eggshell in the stacking context, and therefore the eggshell will sit above the spectacle arms, hiding this part. To clip our spectacle arms, we're going to use the polygon value. The polygon function accepts any number of xy coordinate pairs, where x and y are relative to our element. Here, a polygon of 0, 0, 0, 0, 0, 0, 0, 0 will clip our entire element. And that's because we have 4 points, which are all in the top left corner of our element. If we change our polygon values to 0, 0, 100% 0, 100%, 100%, and 0, 100%, this will be the equivalent of using the inset function with 0, 0, 0, 0. Because the first point is 0, 0, the second point is 100% of the element's width and 0% of the element's height. The third point is 100% of the element's width and 100% of the element's height. And the fourth point is 0% of the element's width and 100% of the element's height. If we remove the last set of points, we get a triangle because we're cutting from 100%, 100%, which is the bottom right corner, back to 0, 0. For our spectacle arms, we can count the points out. 1 point here in the top left, down to a second point somewhere here, a third point around here, fourth point in the top right corner, a fifth point somewhere around here, a sixth point at the base, a seventh point again at the base, and an eighth point near to our starting point. And then we finish back at the top left corner. Let's attempt to make those points. We can have the top left as 0, 0. Then let's try 25% by 55%. And because our spectacle arms are symmetrical, we can go with 75% and 55% for the third point. And then 100% and 0 for our fourth point. We can try 100%, 80% for the fifth point. Let's attempt to use the same x value as the point above with 75%. And it's at the baseline, so 100%, 25%, 100%, and to finish 0 and 80%. And that isn't too far away. If we hop back into DevTools, we can configure the clip path until we get the shape that we desire. Copy that value and apply it in our CSS. Now we've created all of the elements, we can remove the opacity and show our specs, and we can show the eggshell. So in review, we've used absolute positioning and transform to position our element. We used a width and height that matched our image as closely as we could. And then we used a polygon clip path to clip away the pieces of our element that we didn't need. That allows us to create complex polygon shapes by passing in pairs of x and y percentages. These percentages are relative to the bounds of our element. Unhiding the eggshell hides the section of the spectacle arms that we don't need to see. We could remove the background color from our egg and call it there, but we aren't quite done. If we reduce the opacity of our egg and raise the opacity of our image, we can see that our spectacles actually cast a shadow onto the eggshell. And that's something we can achieve by applying a box shadow to each spectacle lens. Let's start by adding a basic box shadow. A box shadow consists of a horizontal offset, a vertical offset, a blur, a spread, and a color. Starting with a bright color allows us to easily see the shadow we're creating. We don't need the spread, but we will use the blur. We can define the size of our blur using our responsive unit. If we look closely, we can faintly see the red shadow around the lens, and we can see that we need to apply a vertical offset so it matches up with the shadow on our image. Let's try a vertical offset that is 20 times our responsive unit. That looks quite close. We could also try 30. And maybe we settle on a happy medium of 25. Looking at our shadow, it needs to move horizontally across, but we also have another issue. Any shadow that goes past the outline of our eggshell, we do not want to show. But we can't use a clip path on the lens because that will remove the lens as well as the shadow. What we can do is duplicate the lens elements and use the duplicates purely for the shadow. Duplicate our lens elements and add a new class, specs lens shadow, which allows us to style those duplicate lenses that have been created for the sole purpose of creating the shadow. With these duplicate elements, we'll be able to clip the excess that we don't need without affecting our spectacle lenses. Let's create the specs lens shadow style, and we can move our box shadow declaration into that style. Now we can apply a slight negative horizontal offset to pull our shadow across a little bit. So let's try calc -10 times var unit, and that looks good for our bottom shadow. And now we need to create this inner shadow on the lens. And for this, box shadow also accepts an optional inset value, which tells our shadow to display inset within our element. We can layer up as many comma separated box shadows as we wish. So let's create a second box shadow, but for this one, let's not have any horizontal offset. Let's keep the same vertical offset. Let's keep the same blur. Let's use a blue color and let's define it as inset. And there we can see our shadow. At this point, we want to clip away the parts of the shadow we don't want to be seen. And for this, we can use a polygon clip path. Looking at our image, we could start at around 50% 0, move along to 100% 0, and then we would need to move down to around 100, 120%. And that's because if we clip to 100%, we will actually clip away the shadow. So we need to go past 100% so we can still see the shadow. So if we say this is 100, 120, then we would move along to say 20%, 120%, and then it would cut back up. So let's try that. 50% 0, 100% 0, 100%, 120%, and 20%, 120%. That's not too far off. Let's jump into DevTools and adjust the styles. Shifting that last 20% down to around 15% or 14% works. It's not quite right. We can see a slight gap here. So an additional point taking us to around this area and then here is likely what we need. Let's try adding another point. Let's try 18%. 100%, and that's pretty close, but now we have a slight overhang. So let's adjust that 14%, let's try 16%, and that looks pretty good. Let's copy that value and apply it in our CSS. At this point, we can define a shadow color. Something with a reduced alpha would be ideal. And we can replace the red and blue that we defined previously. And we can soften the color of those spectacles, remove the image from our HTML, and there we have it, a pure CSS egghead. So in review, we're able to add more depth to our illustration by using box shadow with duplicated elements that we then use a clip path on to clip away the excess. We use a duplicate element because we don't want to clip away the original lenses. The duplicate's sole purpose is to render the shadow cast onto the eggshell.